You spit a lump of black gum onto the ground. It holds your entire life. Your face. Your last meal. Even the invisible creatures living inside your mouth. Nearly 5,700 years later, that ugly little lump will tell strangers more about you than any tool, footprint, or grave ever could. How can something you chewed for a few minutes survive long enough to become a genetic time capsule? The answer begins on the island of Lolland in southern Denmark, at an archaeological site called Syltholm. Today, the area is shaped by construction, fields, and coastline. In your time, it is a shallow lagoon surrounded by woodland, reeds, and rich hunting grounds. You live at the edge of an enormous change. Farming has begun to spread into Scandinavia, yet your daily life still follows the older rhythms of fishing, gathering, and hunting wild animals. Then you pick up a small piece of birch pitch. It is dark brown or black, slightly glossy, and soft enough to carry the marks of your teeth. It looks like ancient chewing gum. But why would you put tree tar in your mouth? Birch pitch begins as pale, papery bark. Heat that bark with limited oxygen, and it releases a thick, sticky substance that hardens as it cools. Long before metal nails, screws, or plastic resin, this material worked as a powerful natural glue. Your ancestors could use it to fasten a sharp stone point onto a wooden shaft, repair an object, or bind separate materials into one reliable tool. A stone blade alone is useful. Attach it to a handle, and it becomes safer, stronger, and far more precise. That simple bond changes what your hands can build. The strange part is what happens when the pitch becomes cold. It turns hard and difficult to shape. Chewing may warm it, soften it, and make it workable again. Your teeth become part of the manufacturing process. Could the same lump have served another purpose too? Birch contains compounds such as betulin, and researchers have suggested that pitch may have been used for dental problems because it has antiseptic properties, meaning it can hinder some harmful microbes. It may also have been chewed casually. Nobody can prove that this particular person treated it like modern recreational gum. The honest answer is that one object could have been glue, medicine, raw material, or something to chew while your hands were occupied. Its tooth marks prove the action, not the motive. Now reconstruct the moment. You sit near the lagoon with smoke drifting between the trees. Someone is shaping flint nearby. Another person is preparing food. You place the tough pitch between your teeth and work it until warmth and saliva make it pliable. Perhaps you ate moments earlier. Perhaps your gums hurt. Perhaps a tool needs repairing before the next trip. Then you press the black lump with your tongue, remove it, and leave it behind. Would you imagine that your saliva has just sealed a portrait of you inside it? Thousands of years pass. The landscape changes. The organic traces of most ordinary lives disappear. No human bones are recovered from Syltholm, yet the pitch remains. That is the first counterintuitive twist. Archaeology often remembers the grand and durable object, but this story survives inside something disposable. In 2019, a team led by Hannes Schroeder at the University of Copenhagen published an extraordinary analysis in Nature Communications. Thijs Jensen, Jonas Niemann, Katrine Iversen, and their colleagues extracted enough ancient DNA from the pitch to reconstruct a complete human genome. A genome is the full set of genetic instructions carried in your cells. Before this study, complete ancient human genomes had been recovered from remains such as bones and teeth. This one came from saliva trapped in a chewed substance. What could that saliva reveal? The DNA showed that the person who chewed the pitch was female. The research team nicknamed her Lola after the island of Lolland. Genetic markers suggested that she probably had dark skin, dark brown hair, and blue eyes, a combination already known among some European hunter-gatherers. Her ancestry connected her more closely to Western hunter-gatherers from mainland Europe than to hunter-gatherers in central Scandinavia. She also lacked the genetic adaptation that allows many adults to digest lactose easily. That fits a world in which dairy farming had not yet reshaped every local body or diet. Yet the most surprising clue may be what her genome did not contain. Lola showed no detectable ancestry from the farming groups, then moving into parts of Europe. At Syltholm, the transition to agriculture was not a clean switch where farmers instantly replaced every hunter-gatherer. Old ways and new ways could exist beside each other. A piece of gum complicates the simple story of progress. It shows you a person living at a cultural crossroads without becoming a farmer herself. But the pitch preserved more than human DNA. It also trapped the oral microbiome, the community of bacteria and other microscopic organisms living in the mouth. The team found DNA from many oral microbes, including species associated with gum disease. They also detected fragments assigned to Epstein-Barr virus, a virus now carried by a large part of the human population. This does not prove that Lola felt ill on the day she chewed the pitch. It shows that familiar relationships between humans and microbes stretch deep into the past. Does your mouth carry a history older than cities? The answer appears to be yes. Saliva also brought traces of food into the pitch. Researchers identified DNA from hazelnut and mallard duck. Those fragments may represent a recent meal. Picture the chain of evidence. A duck is caught near the wetland. Hazelnuts are gathered from the surrounding vegetation. Food passes through a human mouth. The same mouth chews birch pitch. Millennia later, genetic sequencing turns those invisible leftovers into a menu. No written recipe survives. No plate is required. Your spit remembers dinner. The Syltholm discovery was not an isolated curiosity. At Husby Clef on the western coast of Sweden, archaeologists found chewed birch pitch dating back more than 9,500 years. Natalija Kashuba and colleagues recovered human DNA from 3 pieces and connected the chewers genetically to Scandinavian hunter-gatherers. A later metagenomic study led by Emre Kurdok examined microbes in those mastics and found signs associated with poor oral health. Mastic simply means a substance softened by chewing. Together, these discoveries show that ancient pitch can preserve population history, diet, health, and personal contact in places where skeletons may be missing. Why does sticky tree tar protect such fragile information? When you chew pitch, saliva and cells become embedded throughout a water-resistant material. Birch pitch can discourage microbial activity and slow the chemical processes that normally destroy DNA. The same properties that made it useful as glue also made it an accidental archive. Your ancestors did not invent genetic storage. They invented and handled the material that performed it by chance. That is the second twist. The technology mattered twice, first in the ancient world and again in the modern laboratory. Experimental archaeologists Paul Kozowick, Marie Ceresi, and their colleagues have shown that useful birch tar can be produced with Stone Age materials and without ceramic containers. The process can be simpler than researchers once assumed, yet it still demands attention to fire, bark, timing, and the behavior of changing materials. Ancient glue was not a crude substitute for modern technology. It was technology built from controlled heat and accumulated knowledge. Each generation could learn which bark worked, how long to heat it, when the pitch was ready, and how to soften it without ruining it. How much science can exist without a written formula? Enough to transform stone, wood, and fiber into composite tools. A composite tool combines separate parts so the finished object can do more than any part alone. That principle still surrounds you. A phone, a bicycle, and a building all depend on materials joined together in deliberate ways. Birch pitch belongs near the beginning of that long engineering story. Yet its most intimate achievement was never planned. It carried one person forward through time. Lola was not preserved because she ruled a kingdom, commanded an army, or built a monument. She may have been remembered by her community, but no written name survives. The name Lola is modern. Her own name is gone. Still, the pressure of her teeth remains. Her cells remain. Traces of her food and mouth remain. The smallest habit defeated the silence that swallowed almost everyone around her. What ordinary object are you leaving behind right now? A cup with a fingerprint. A tissue holding cells. Gum under a table. Modern life produces endless biological traces, but most feel meaningless because they are common. Syltholm reverses that judgment. Common things are often the closest records of how a person actually lived. A weapon can tell you what someone made. A monument can tell you what a society wanted remembered. A chewed lump can tell you what entered one human mouth on one unremarkable day. So the next time you chew gum, the action is not as modern as it feels. The flavor, wrapper, and synthetic base may be new, but the rhythm of jaw and teeth connects you to people who softened natural resins thousands of years ago. You carry your genome, your microbes, and your latest meal into that small object without noticing. To you, it is rubbish. To the future, it could be testimony. You spit a lump of black gum onto the ground. It holds your entire life.